Yeah, so yesterday we have seen how to create the interface and how to access the interface methods and how we can implement the interface methods using implements keyword, and also how to cast the child class object to parent interface, and how to perform the multiple inheritance using interfaces we have seen, right? And also the features of interface if we create some method or variable inside a interface. Okay, so by default, what are the features it will have? Those we have discussed yesterday, right? And also abstraction also we have discussed. So in both the cases, both the cases, we cannot create the object because those are incomplete classes. If you don't implement the logic, which becomes a incomplete method. If you have single incomplete method, at least one implement method, one unimplement method in your class, which becomes incomplete class. For incomplete class, you cannot allocate the memory, which means you cannot create the object. It won't allow you. JVM won't allow you to allocate the memory for your data for the incomplete classes. So that is the reason, with the help of child classes, you will complete the incomplete class. By extending it, you will add the new logic and override the unimplemented method. Okay, override the unimplemented method that we have seen till yesterday. So from the interfaces, we have few more concepts. If you want to learn new features of Java, you must aware of those concepts. Okay, so one is we have some special kind of interfaces. So basically those interfaces we call it as marker interface. Okay, somewhat it is required for our testing, and also some interfaces we call it as annotations, and we have other interfaces, basically we call it as functional interfaces. Okay, so if you want to learn API automation testing, you must aware of marker interface. So we have serialization, synchronization, and threading. These concepts we have in Java. Okay, those are not required for Selenium automation testing, but those are required for API automation testing if you want to serialize the object. Okay, what is serialization? If you want to know, you must aware of marker interface. Okay, so similarly annotations in our programming also we are using annotations. Okay, so let me see one show you one annotation. See, override. This is annotation. See, what is the general meaning of annotation? So in our school days, if some important point, like suppose if some important point is there in the topic, okay, our teachers used to ask to underline that line, right? When they are dictating, underline it. Okay, so that is called annotation. Okay, highlighting some information of some topic. So here, if you want to highlight something about this method, you have to create the annotation. Okay, which represents, okay, something is highlighted in this method. Okay, why here we are highlighting some already existing method is there, so that you are overriding, which means this method you are highlighting. Okay, it is a override method. Okay, so it is a default annotation. We can also create the user defined annotations, and also we have functional interfaces. These are very important functional interfaces. Okay, so these we will discuss, but if you want to understand these three type of interfaces, you must aware of inner blocks of class, inner classes, inner interfaces, anonymous class, static blocks. You must aware. Then only you can understand the marker interface. And so marker interface, it is a separate one. Okay, so annotation also it's a separate one. If you want to understand functional interface, this is important basically. So annotations you won't create. Marker interface also very rarely we use. Functional interface we frequently use in Selenium. 90%, 95% people doesn't know doesn't aware of this functional interface who are in testing. Okay, if you learn it, if you write your programming with the help of functional interfaces, okay, you will get impressed by your interviewer. Okay, so first, if you want to learn functional interfaces, okay, we must aware of inner classes and anonymous class. First, we start with the inner classes and the anonymous class. Then we can move to these topics. Okay, so let me create one new package. So package name itself inner classes. So let me create 1 second. Give me a minute. Yeah. So if you want to create okay, let me create one new package. So package name is inner classes. Inner dot classes. Okay, inside that I'm creating one class. Class name is outer class. Okay, just to show the difference between the inner class and the outer class, I'm giving the name as outer class. Okay, so let me create with public method also. This is my outer class. Okay, I have outer class. So if you want to create, okay, so in starting of our classes only, I think I have explained what are all the things we can create in the class. Okay, so I think here somewhere I have explained. In day 2 now. Yeah. See, we can create class inside another class, interface inside another class, and the class without name, with name also we can create. Okay, first one by one we'll discuss. First, I'm creating class inner instance class or instance inner class. See, if we are creating inside a class, if we create anything that can be instance or static, right? So first I'm creating instance inner class. I want to create static inner class. Static. Okay, when we say static, which starts with the static keyword. Okay, you can create class in instance class without name. You can simply create like this. No need of using class keyword also. Okay, so let me. So this is inner instance class. So this is inner static class. Inner class without name. Okay, so technically this class we call it as anonymous class. Anonymous class. So now this one, this is the method. So this block. Okay, this is a anonymous class. Okay, this is also inner instance class without name. Inner instance class without name, which call it as anonymous class. Similarly, we have inner static class without name. Okay, technically this we call it as static blocks. static blocks. Okay, if you want to create that, just use static keyword. Static. Similarly, you can create interface enum also inside the class. Okay, if you want to create interface, yes, you can create interface inner instance interface. You can create. If you want to create enum, yes, you can create enum inner instance enum. Okay, so you can write like this. But how to access, if you create the inner classes, how you will access those inner blocks? How you can access these inner blocks? How you can access? See, suppose if you have a static variable, suppose let me take static int a equals to 100. How you are accessing this? You can directly access with the help of outer class dot a, right? Similarly, this inner static class also you can directly access with this class name dot static inner class. But coming to access inner class, instance inner class, what you require? You require a object, because it is an instance. You cannot access directly. By default, the memory won't be allocated. Similarly, this anonymous class, inner anonymous class also, you cannot access directly. Once you create the object, then only you can access. Coming to static. Okay, if you want to call this static inner class, it doesn't contain any name. It doesn't contain any name. Okay, in this case, what happens is, without calling this method, whenever you execute a program, first this block will be executed. This block will be executed first. Okay, if you want to see, let me write. So here I'm writing inner static class without name or static block. Okay, so this is my main method. So here I'm writing one more statement, hello Java. Okay, if I execute, so what it will, so whenever we execute any Java program, first what it will execute? It will execute the main method. Okay, whatever we call inside the main method, that only will execute, right? Okay, from day one onwards, that only we are seeing, that only we are discussing. Okay, from the main method only we have to execute everything. So when I call main method, when the program execution starts, immediately the static block will be executed before executing the statement. So let's see the output. See what it is printing. First, it is calling the static block by default, because while loading the class only, the memory will be allocated for this static members, right? For this and also this. So while allocating the memory for the static member, by default, it is calling the statement. Okay, by default, because it doesn't contain any name to call. That is the reason by default it is calling. Your compiler itself, not compiler, your JVM, while loading the class, it is calling this method. I mean this block. After that, it is whenever it, so this statement, when it prints the statement, when executing the program, right? So we have seen the like the flow of our execution, right? So let me open that screenshot. You will get more understanding. So here, I think first day only, I think I have explained it. Yeah. So here, see, so your virtual machine, Java virtual machine. Okay, so after compilation, there are again two more stages. One is loading and executing. Okay, before executing, your class file must be loaded. Okay, while loading the class, while loading that class file, it is automatically like it automatically executing this block because it doesn't contain any name. So simply it is executing. Okay. So coming to anonymous class. Suppose if I create a object. Okay, so let me print some statement into the anonymous class. So inner instance class without name, which is anonymous class. Okay. So if I create the object, so before executing this line, I'm creating the object for my outer class. If I execute while creating the object, if you create the object, what happens in the backend? For your instance members, memory will be allocated, right? For instance members, instance variables and also methods, memory will be allocated so that you can access the methods and variables with the reference. But coming to inner instance class, anonymous class, it doesn't contain any name to call explicitly, right? So what happens is whenever you allocate the memory for your class, that time this will be called automatically. So if you execute, first it will call the static block, then automatically this part will be executed. So let me run it. See, inner instance class also executed because it doesn't contain any name. Well, the moment you create the object, it is allocating the memory for this class, inner instance class without name, and it is directly executing this print statement because it doesn't contain any name. Okay. So coming to your inner classes, inner instance and static class, which are having the name. Okay. Suppose if you want to call the, okay, suppose if we have some instance variable int b equals to 200. If you want to call b into static method, how you will call? Suppose I want to print b. Okay, you must call with the reference, right? Otherwise you cannot access. Suppose if you don't use the reference, you will get the error because it is a instance. So for instance members, you already allocated the memory and you have given the reference. So with the reference, you can access that memory data. Now you can print it. Similarly, so if you want to access inner instance class, so you must call with the object. Okay, this object. So you must call with dot. Again, this is a class. Okay, suppose if you have some variables, static int c equals to some 300, int d equals to some 400. Okay, so why c it is okay. Inner instance class basically, so we cannot use the static because the class itself is a instance class. In that case, you should not use static. How it will allocate the memory if you use the static? It won't allocate. You cannot use the static here. Okay. So if you want to access C and D, what you have to do? Let me write some method also. Void method 1. You can print some statement as so the statement is inner instance class inner instance class method 1. Okay, inner instance class method. So let me create variables here also in the static class. So for the differentiation purpose, I'm giving the different names. You can maintain the same name because these blocks are different. Okay, so this is 500 and this is 600. So let me make it as 2. So inner static class method 2. Okay, so now, so these are the inner blocks, inner static class and inner instance class. So if you want to access this inner instance class, you must use the reference of your outer object. And if you want to access the inner instance class block, variables and methods, again you have to create the object for this, right? So what you have to do is you can simply call like this, new your object that you can assign to your class. Okay, so with the help of this, you can call your method 1, or you can call C, you can call D also. Okay, if you want to print it, you can print it. Okay, if I run it, inner class method 1 will be printed and also the C value is printed. Okay, similarly, static class, inner static class. How you can call the static class? Object is required, not required, right? So you can simply call outer class dot okay, see here it is showing inner instance interface, it is showing inner instance inner class and also static inner class. Okay, let me select this. Okay, here what I have to do, one second. So static members you can directly access with the static class. With the directory you can access with the is not showing up. Wait. Okay. So let me make it as static ones. Okay, if you make it as static, so generally, so when you create the static block, okay, so the static block you are creating is it will be allocate some memory for this block, right? For this class. So the purpose of using this class is to create the memory at the time of loading the class. So again, you should not use the instance members. You can use if you want, but it's not a better approach. Okay, so it's better to use the static inside the static. Static inside the static. Okay, so if you want to create the object or if you don't want to use static here, let me write one more method, instance method, let me write. This is method 3. This is method 3. Okay, instance method. This is the instance method. So now, so I can call E and also I can call static method directly, method 2. So if I want instance class, again I require a object of my static class. So new object. Now no need to specify class name here because it is a static. So if you want to assign to your static class, you can directly static inner class. Like this you can assign. Or you can also assign like this. Both are fine. Okay, so this notation also a little bit important. If you are accessing outside of your class, suppose if you create some other class, that time if you want to access the static inner class, so you must specify this. Okay, if you are creating outside the class, because inside the class no need to specify this class name, but for our identification purpose we are doing it, right? So you can simply call your method 3 simply. Method 1, method 2 and method 3 also you can call. Okay, are you getting what I'm explaining? The same thing, whatever we discussed about the instance variables and instance methods, static variables and the static methods, the same thing we are applying here. Okay, so here also I think we can use, no, here we cannot use. It is allowing access. Yeah, it is allowing access. So to represent the, because you already assigned the object. Okay, so here if you make it as, again, if you remove static here, you will get the error. See, if I remove static here, so directly I'm getting the error here. I cannot create direct object. Again, I require a parent class object. Okay, so you must remember this. Most of the time we use inner class, inner instance class we use sometimes. Okay, in Cucumber also I will explain this one, Cucumber framework. Okay, most of the time we use this anonymous class. The anonymous class is whenever you create, see, if you observe here, so one more thing you need to observe. So look at the output. Okay, so here anonymous block is all right. Okay, this is fine. So let me do one thing. Okay, whenever you create object. So let me create one more object here. 2. So when I create the object in backend, what happening? Again, anonymous block is creating, right? Which means one unnamed object in the backend, one unnamed object is creating. One unnamed object is creating in the backend. That is unnamed. Okay. So unnamed object, how you can call? You cannot call, right? Unnamed object, you cannot call. So that is the reason here, if you want to write some methods, it will not allow you to write the method. Suppose if you want to write it, this is a class. Inside that you can write the, generally you can write the method also. And also you can end this with semicolon also. Static blocks also you can end with semicolon. So here, if you want, you can create variables that you can print if you want. That you can print. Okay, so A. But if you want to write methods, you cannot write. Okay, let me write some method while method 6. You cannot write the methods. Okay, because it doesn't contain any reference, you cannot call. And again, so whenever we call the method, that time only, okay, in the method area, the memory will be allocated. One method is executed. Again, once method execution is done, again it will be erased. Okay, that also we have discussed. Okay, heap area, static area, and method area. So you cannot call this method. So this method will not be available because this is a unnamed object. This doesn't contain any name. So you cannot access this method. Okay. But if you want to write method inside a anonymous class, it is possible. How it is possible? Okay. So what you can do is you can write methods inside a anonymous class by providing some reference to it. If you provide some reference to that class, okay, it will allow you to call those methods. Okay, so if you want to write anonymous class, you can write in the method also like this. You can write in the method also this anonymous class. If you want to give some reference, you can give the reference outer class object reference also you can give directly. Suppose if you write some method here, void method anonymous, just example. Let me print some statement. Okay, anonymous class method. You can call this method with the help of outer class object. Method, it is not showing. So here we have one rule here. Okay, again, if you want to call, this is a separate object. Okay, this is an anonymous class object. You are just provided the reference. Okay, you have just provided the reference. Let me illustrate with the example so that you will get the clarity. So yeah, to get the clarity, so what we are doing here, that I will explain through the diagram. So you have one object and also you have another object. So by looking at this program, see, when you use this method, what happens in the backend? Object will be created, which is a type of outer class, right? So here, this object is created when you use that notation, and for that you are giving the reference as outer class 2. Okay, outer class 2. So now you are creating the object along with the anonymous class object, and you are providing the reference only. It doesn't contain any type. It doesn't contain any type, which means, so whenever you create the objects like this, okay, so let me explain you in a different way. So let me remove it. So whenever you create object for two classes, it can be anonymous class or normal class. What happens in the backend? It will create the submemories. So for upcasting and downcasting also, we have taken this example. This is our anonymous class. So here for this you have some name, that is outer class. This is a type of outer class. Okay, for anonymous class you don't have any name. Okay, this is a outer class object which contains some methods. Okay, some methods like inner classes and methods. Method 1, inner classes, and also you have static blocks and everything. So in this anonymous class you have what you have? You have method, anonymous method. What is the method name? So let me take it from here. Method anonymous. Method anonymous. Okay, for both you given the name as some reference you given for both the objects. So when you call, okay, method 2 with some reference, with this reference, okay, our compiler what it does, when you assign some type to it, it won't directly go to this method. Whenever you are calling, okay, execution will be start from the bottom only, okay, bottom to top approach only. But when you assign some type to this reference, your compiler directly go to this particular part. So here it will, so in this, here it will go and it will start searching the method. Okay, but this method is not available in that memory. This method is not available in that memory. Okay. See, this method is not available in this memory. So now, if you're trying to call this method anonymous with this outer class reference, it is not accepting. Your compiler is giving the error. So that is the reason you are getting the error. If I try to call method anonymous here. Okay. If you try to call method anonymous here, it is directly going. So that's what upcasting and downcasting. If you don't understand the upcasting and downcasting, again you will get confused. Okay. When you do the upcasting, your compiler directly goes to the type, whatever the type you are specifying to the reference, it will directly go to that particular memory location and it will start searching the method. If it is not available, your compiler, it won't allow you to execute your program. Okay. Suppose if you create the same method here. Let me create method here. Same method here. But this is not anonymous class method. This is outer class method. Right? Method name can be, you can put outer class method. So whenever you do like that, okay, if you call method anonymous from outer class object, what happens? Okay, it comes to this location, it checks whether this method is available or not. Okay, so it will check the method availability. Method availability. This method is available or not. Yes, it is available. But when you try to execute this program, execution always starts from the bottom only, bottom to top approach, irrespective of the type of the object. Okay, when you call this method, it won't call this outer class method. Okay, if you run it, it prints the anonymous class method. See, anonymous class method is called. Okay, by default, it overrides. By default, it overrides the method which is there in the reference class, reference object class. Okay, getting or not? Okay, so what is the advantage then? Somebody tell me, anyone from this class, what is the advantage? Like if we provide the access like this, what is the advantage? If we like create like this, what is the advantage? Okay, let me explain.
Execution speed increase.
Come again.
Execution speed increase.
Your voice is not clear.
Execution speed increase.
Yeah, so execution speed increases. That is fine. Okay. So, and also we have one more advantage. Main advantage is, okay, so execution anyway. Okay, so execution speed is okay. Okay, so based on the reference you are providing, it is directly it decreases the compiler time, searching time. That is fine.
Yes.
Okay, so one more advantage is, suppose if you have an interface. Suppose if you have an interface, if you want to use that interface in your class, what you have to do? Okay, so let me create one interface here. Okay, so here, let me take as calculator only, for example, calculator, finish it. So copy methods from calculator. This is your interface. Okay, this is our interface. Suppose if you want to use this interface to your implementation class. Okay, let me create class, implementation class. What you have to do? Suppose if you are implementing, use implements. Implements. Okay, implements. So here what I'm doing is the calculator I'm implementing. Okay. So whenever you implement your class, you must implement the unimplemented methods. These methods you have to implement, right? Okay, that is the thumb rule. Okay, everyone has to do that. There is no exception for that. If you want to implement some interface, you must implement the methods of its methods of interface, right? If you have some unimplemented methods, you have to do this, right? So how can I access the interface without using the implements keyword? Can I create the object for my calculator? No. I must use the implements keyword, then only I can access the interface. But using anonymous class, you can avoid that dependency. Using anonymous class, you can avoid that dependency. How we can avoid? Okay, let me create the main method here. So now what you can do is you can directly write like new interface like that you can write. Okay, this reference you can give it to the anonymous class. Okay, again it is asking to add the unimplemented methods. So these methods you can directly put over here. Okay, instead of implementing the calculator interface directly to your class, remove this dependency and you can assign into your calculator reference only. Generally, you cannot create the object for your calculator interface, right? But with the help of anonymous class, you can create the object for your interface. Now, if you want to call the interface methods, you can directly call the methods from the interface reference. Okay, here we are avoiding the dependency. Here we are avoiding the dependency of implements keyword. Okay, so wherever you require, so there just declare it. Otherwise, do one thing. So write here. Okay, so make it a static. Make it a static. You have implemented here. Suppose if you want to call this calc dot method, you can call, and if you want to print it, just print it. Okay, pass some 30 and 40. You are getting the result, right? You are getting the result. So here, if you want to make this reference as public, protected, or private, that you can do, right, with the help of, see here, instead of public. Okay, so here we must use the same notation. So whatever the like methods we are creating here, by default all these are public, right? We must create as a public only. Okay, the signature must be same. Okay, you can avoid the dependency and you can directly call with your interface reference only. Of course, we will do the same by assigning the child class object. We can assign the same, but here no need of assigning the child class object. You can directly do with the interface itself with the help of anonymous class. Okay, so the one more advantage with anonymous class is for instant purpose, you can use it. Suppose these methods, okay, up to this. So here only I can use. Again, if I make it as a private, can I use this calc C outside this class, some other class? I cannot access, right? Inside this class only I can access. So again, you can provide the more security to your methods, and also access also you can provide similar way. Okay. So with the help of anonymous class, what you can do is you can give the reference of some interface or some class interface you can give, and using that reference you can directly call the interface methods. So not only this calculator, suppose if you want to, okay, so here we must do this. Let me do one thing. What I have to do is, so if you use implements, we must create the methods. Why we have to create? If you use implements inside a class, why we have to implement those methods? Because in the child class, if you want to allocate some memory, okay, for these names, you must implement, right? Otherwise it won't take from the implementation calculator, because this will comes under again the anonymous class object. Implementation calculator object will be different, calculator object will be different, type will be different. Okay, whenever you call, it will go to implementation calculator, it cannot find these methods. This is block is different. Okay, so like that we have some restrictions. Suppose if you don't want to use the implements, okay, you want to use the interface as a reference for your methods, then you can use the anonymous class. In the anonymous class, you can create the methods, you can override the methods, and those methods you can give the access to the reference, whatever the reference you want, there you can give the reference. Okay, so yeah, so based on this anonymous class usage, we have some special kind of interfaces. One of among those are functional interface. Okay, first I discuss this one. Functional interface. Okay, so how to use functional interface? Let me create some separate package to explain that. So package name is functional interface. Functional.interface. Okay, so interface one I have to use, because when we use interface, we have default package. Not default package, the keyword name itself interface, right? That is the reason we cannot use the keyword names for our variables or for our user defined classes or packages, especially packages, because packages most of the time we create with the small letters. All keywords are in small letters, so it won't accept. So let me create new interface, functional interface example. Okay, what is functional interface? Suppose you create a interface which contains only one instance method. Only one instance method. Static methods, you can have a number of static methods. Okay, if you want to create an interface with only one instance method, so let me create int, or let me create void sum of two numbers. So here you cannot create the implementation, right? Okay, if you have only one method in the interface, that interface you can call it as functional interface. Okay, functional interface. Okay, if you want to specify this is a functional interface, you can use @ functional interface annotation. What is annotation? I will explain. Functional interface annotation. Suppose if you create one more method inside the functional interface, it won't allow you. Suppose if you take int or 1, it won't allow you because it is not functional interface. It is having more than one method. Let's make it a static. Even though you make it a static, it is not allowing you. So which means the functional interface can contain only one method. Why only one method? So from these functional interfaces only, the new features, the Lambda expressions and method references came into the picture. Okay. So whenever you have this is an interface, only one method in the functional interface, there you can use the Lambda expression. Okay. So let me create one class, new class. So here class name is access functional interface. Access functional interface. Let me create with the main method. So now how to access that interface? Suppose if you want to access any interface, what you have to do? Okay, so if you want to use any block in Java, either you create an object, okay, or you have to implement it. So here you cannot create the object because it is an interface. Suppose if you implement functional interface. In this case, what you have to do? You have to implement the unimplemented method, right? You have to implement the unimplemented method. So now child class reference you can provide to your parent class interface, then you can call the method. Which method it is? Sum of two numbers. So here you will implement the logic, right? Sum of two numbers. Okay, if you run it, this is the common approach what we are following in the interfaces. But if you have only one method inside the functional interface, I mean one method inside the interface, in this case, what you can do is instead of writing the method here, or what you can do if you don't want to implement what you are doing, if you don't want to implement with the anonymous class also, we can override the object, right? That also we have seen with the usage of anonymous class. Okay, if you call sum of two numbers again, you can get the same output. So now coming to functional interfaces, so if you have more than one method also in the interface, you can directly access, that is fine. But coming to functional interface, whenever you have only one method, that only we are calling as functional interface, right? So in this case, what we can do is instead of writing override, public, method name, all these things, you can remove everything. This part you can remove everything. Okay, just simply you can write this. You can simply put just add. Okay, so let me comment that and let me write it so that you will get the clarity. So now you have method inside interface. With the help of anonymous class, you are overriding that method. With the help of interface reference, you are accessing. That is fine. Okay, this is the anonymous class usage. But coming to functional interface, so functional, it can be functional interface or non-functional interface. Okay, whenever a interface containing one method, that generally we call it as a functional interface. Okay, whenever a interface is containing one method, in that case, instead of writing like this, what you can do is simply you can write, so method, how we are representing the method with the parenthesis. Just put parenthesis and put hyphen and right direction symbol. I mean greater than symbol. Okay. So here you can write the print statement. Whatever the print statement you want to write, that print statement you can write here. Okay. So now if you call sum of two numbers, it will print the statement. Why it is printing, I will explain. See, again it is printing sum of two numbers. Why? Because in this interface, we have only one method. That is the reason it is able to call this logic. Okay. So this notation we call it as lambda expression. Okay. Or method without name. Method without name. We can call it as method without name. So here we are not using any name to override the interface method. But still we are giving the access, which means, so here, whenever you are not providing the name, people will confuse, right? Okay, what like this logic, which one it is representing. Okay, so for instance purpose, you can use the this anonymous class. You can implement the unimplement methods of abstract class or interface. Okay, whenever you have single method, you can directly use the lambda expression. But if you have more than one method in the interface, you cannot use the lambda expression. Okay, so let me put one more method here so that you will get the clarity. So you will directly get the error where, so here you will not get the error. This is a normal interface. But coming to here, you cannot write the lambda expression because your compiler confuses whether to call this method or this method because we are not providing any name to lambda expression. Okay, so you must have only one method to use the lambda expression inside a interface. So how we can highlight this method? So why we are using annotations? The annotation is nothing but if you want to highlight some information. Okay, so you have to put some box, or if you want to like highlight that, you will highlight with the under you will put some like underline, right, to the paragraph if it is important, if you want to highlight that topic. Okay, some point if you want to highlight, you will put some box or some underline. Similarly, so some people might confuse, right, while writing the while writing these lambda expressions. Okay, if you put at the rate functional interface annotation, okay, so it takes as a functional interface. Now you will not get any error. Suppose if you change anything here in the interface level only, you will get the error. Okay, in the interface level only, you will get the error. Okay, so for execution, it will not give any error. Compilation time only it is giving the error, right? Okay, so like that, we can avoid few mistakes. Okay, annotations we use for that purpose only. Annotations generally we use for that purpose. Suppose, let me okay, in the functional interface, okay, where it is we use inner classes, right? And calculator example also I have shown you, implement calculator. So here you are writing in this part. Suppose you want to write some method in the implementation calculator. Okay, so modular division, let me write. This is mod division. Okay, if you want to put some override annotation here, is there any meaning for it? Is there any meaning for it? There is no meaning, right? Because you are not overriding any method with this new logic. Suppose if you have the same method in your interface, that time you can use override. Okay, but if you are not overriding anything, if you put the annotation as override, okay, it will notify you there is no method to override. Like that you can consider. And similarly, let me take, okay, so instead, suppose if you don't provide the override, okay, here also it will accept, because these methods already are overriding. Even though you put override or don't override, it will take. Okay, so in the interface I have, or interface or class, I have some other method. Let me take some class example to explain this so that you will get clarity for annotations. Okay, so here overriding and overloading polymorphism is there, right? So here arithmetic operations. Okay, overloading of arithmetic operations. This is fine. Arithmetic operations. Yeah, you are extending arithmetic operations, right? So now let me take one method. Method name is void mod division. Mod division. So here you are performing some mod division, modular division. Okay. Now, what is the use of annotation? I'm explaining here. This is the modular division. Okay, it is returning some value. That is fine. This is a percentile B. Okay. So now I want to override this method in my child class. Okay, overriding, I will go. It is extending the arithmetic operations class. So let me write this method as mod division. Somebody has overrided like this. Okay, here what I do is, in the modular division, after modular division, I want to add some 10 value in the logic. Okay, if I created object for my child class, when I call my modular division from my child class, okay, suppose 10 and 3, when I pass, what's your expectation? What's your expectation? When you call modular division, when you pass A and B, 10, 3, 1 plus 10, 11 you should get. Okay, but while calling, somebody has called modular division like this. Okay, what is the output you are getting? You must get the 11 output. Okay, so let me print it. Let me print it. See, here we are getting 1. Here we are getting 1 instead of 11, we are getting the 1. Why? Suppose if I change it to modular division, this one, I will get 11. 11 I'm getting. But somebody wants to use the modular division with the new logic. By mistake, they call the modular division. Okay, this is, you are not overriding the method. So it becomes, this method is different and the parent method is different. Okay, whenever there is a typo errors. Suppose if you want to override a method, your intention is to override the method, right? So in that case, if you annotate your method with @override, okay. So now if this method is not available in your parent class, it shows the error. Hey, there is no method to override. Okay, so there might be some typo error in your method, or this method is not available like that, it will show. The method mod division of type overriding arithmetic operations must override or implement a super type method. So per type means the parent class method it has to override, but it is not there. Okay, if you put it as division, it will not give the error. So now if you execute, so it will call the new method always. That is the use of annotation. We can also create annotations, user defined annotations. If you want to specify some variable or some method or some class, if you want to highlight that class, you can also create the annotation. Okay, how to do that also I will explain. Okay, so coming to Lambda expressions, functional interfaces. So whenever you have only one method inside a interface, that time only you can create the Lambda expression. Otherwise you cannot create. Okay, we have one more thing. Similar way, we have one more thing. Method references. Method references. So method references are similar to Lambda expressions only, but here what we do is instead of writing logic here, you will give the reference of another method. You will give the reference of another method. How we can do that? So let me show you some example. So here, what I do is, so let me create one method void method 1. It can be any method. It can be any method. So let me print this statement inside this method. This is method 1. Method 1. So now what I can do is, so let me make it a static. We have two types of method references. Okay, method references and Lambda expressions I will explain once again. Okay, this is the important topic. New my object. Inside that object I have one method, that is method 1. Okay, so why it is showing error? Rename. Okay, so some other name it is asking to give. So now if I call sum of two numbers, what it has to display? Sum of two numbers, what it has to display? So it will display the child class, this is not child, there is no relation. Okay, but it will call the other class method. Okay, you can bypass it. See, when you call, so let me comment this line, Lambda expression. Let me give method reference, method 1. Method 1 it is printing when you call the sum of two numbers, because there is no implementation at all in the functional interface. You are providing some reference method to it, that we call it as method reference. So when you are creating the object, which means it is a instance, so that we call it as instance method reference. We also can call static method reference. So this is method 2. Static you can make. So when you create the static method, no need of object, right? So simply you can assign. Let me create one more reference. This is method 2 or static method 2. This is instance method 1. Okay, here this is 3. So I don't want to use the instance method. So you already created the static method. Simply you can use static method 2. So if you call the sum of numbers, method 2 will be executed. So that is the reason they given the name as method reference. Okay, you are calling the method you are giving the method reference to your interface method. Which method reference? Some class method reference. When you call sum of numbers, this method will be executed. See, method 2 is executing, static method 2. In this line, it is executing the instance method because you are calling from the here also you can use 2. So if you create the object, we can use it for instance and static, right? Okay, here if you use 2, it will be called 2 again. Why it is okay? We have some limitations to use again. So static, when you use static, so you have to follow this notation. So instance methods you cannot with the instance reference you cannot refer the static method even though it represents the same object. Okay. Okay, so with the help of functional interfaces, okay, you can use the lambda expressions. And also you are writing method references. Okay, so marker interface, as of now it is not required. Okay, so we have some interfaces, those doesn't contain any method, any variable or anything will be available in that interface, that we call it as marker interface. Such kind of interfaces identified by JVM, and it assigns some special characteristics to that interface. As of now, it is not required. Okay, if anyone is required, that I will explain. We won't use anywhere in our Selenium. But annotations we are using, right? Annotations we use everywhere. Okay, so if you know what is the use of annotation, use of annotation we already seen. If you want to create the annotation is a interface. Okay, so let me give you one example. After that, we will stop our session for today for annotation, and tomorrow, and also one more thing. So let me explain that well. Functional interface example 2. One more functional interface I'm creating. Functional interface 2. Okay, let me explain 2-3 example on this because it is important. Into what I'm doing is I'm creating int addition return here addition of 2 numbers int a int b. Okay, return a plus b. Okay, so here you will not write any logic, right? This is a functional interface. So I created class, so I should change it to interface. That we cannot directly change. What I will do is copy the name or copy the logic also. So delete this class. I like whenever we creating the functional interface, it must be a interface, right? So new interface. Okay, functional interface 2. Finish it. Same logic. Okay, here why we are getting error? Add body. Okay, this is interface, right? Yeah. So if you want to call this method, okay, whenever you don't have any parameters and void, okay, you are simply putting parentheses, right? So if you want to access this interface, which is there in the interface, functional interface 2. Functional interface 2. So earlier, whenever you don't have the parameters, simply you are calling this, right? So whenever you have parameters like A and B, you are directly calling that method, executing that method, addition method, 10, 20 you can pass. Okay, you can return A plus B. Okay, whenever you are putting like this, just put the curly braces. So here some 5. So interface name correct only, right? This is the functional interface 2. So let me refactor this. Yeah, refactor, rename, just rename it. So there is nothing change. Go to access functional interface 2. Okay, so what is the error we are getting? Token. Why we are getting this? Whenever we have more than one parameter, it must allow 2 parameters. This is also fine. Okay, let me do one thing. Okay, sorry. So here I should not pass the numbers. Okay, A comma B I have to pass. I just confused about there. Sorry for that. Okay, and this curly brace also not required, it seems. So let me try to remove this. Yeah, like this also you can write. But whenever we use extra things, yeah, so this time it is asking curly brace, just put it. Okay, now if you want to call addition method with this reference, you can simply call the addition method and you will pass the 10 and 30. Okay, see, but method will be executed from this logic. See how much code we have decreased. If you want to write addition method logic, you are writing some 4 to 5 like some 3 in a line number of code you are writing, right? But we are writing in a single line. Okay, functional access functional interface. If you run it, see, so this if you print, this will be printed because it is returning the value. So some 40 will be printed. Suppose if you have only one parameter, let me create one more. Here I want to pass only one parameter. Okay, only one parameter. So in access interface, how you will access? So the same thing. So 6. So I don't want to pass. So here this is 3, right? So 3. It is accepting only one value. So that is a value. Instead of putting parentheses like this, this is also fine. A plus 5 I want to do every time. This is also fine. Instead of this, the same thing you can write like this. Okay, without putting the parentheses also. Again, people will confuse. Either this is a method variable or local variable. People will confuse. Like that, you can provide the security to your code by writing your program in this functional way. See, 15 is printed when I call addition method. Okay. Yeah. Now, this is the usage of Lambda expressions. This is the usage of Lambda expressions. Suppose if you have functional interfaces, you can use Lambda expression. we have some default functional interfaces. Those we will discuss once we complete the collections. So now let me explain annotation. Okay, annotation also we will discuss tomorrow. Why to like spend time today? Okay, annotation also we will discuss, and after that I will explain exceptions. Once we done with that, we can directly move to the collections. Okay, after collections, file systems. So in 3 days, 3 to 4 days, Java will be completed. So today Friday, right? By Monday, Java will be completed. From Tuesday onwards, we will discuss the Selenium. Okay.